So, if you have questions, as always, let me know. And we're going to get started. All right, everybody see the lesson?
Yes.
Yeah.
Okay, so because I can't tell whether you are with me or not because of the way the screen is right now. But, so we have this gentleman over here on the right. Everyone hopefully sees this guy.
Yep.
And he's got some pretty awesome facial hair, which is typical of the time period, apparently. And we could always darken it up a little bit here. All right, so this over here is, whoops. So we have Pythagoras over here, who is a Greek philosopher. And he actually had a cult of people that worshipped, or I guess followed the things that he taught. So anyway, one of the things he taught, because he was a mathematician, is about Pythagorean theorem, which maybe you are familiar with. It. Are you guys familiar with Pythagorean theorem already? I'm sure you probably learned it in grade 8.
Yeah.
You did?
Yeah.
All right. So let's see if this looks familiar to you. So if you look at the triangle that we have here, all right, we're going to construct a square from each side of the triangle below. So what I'm going to do is I'm looking at the dimensions of this triangle, and I'm going to try and match it. So, for example, let's go off to the side here. Right? So if this side here is side A, right? Like that. Let's go like this. I'll change it. Here's A. This is side A. So this is also A, this is A, this is A. So this is technically, if we went for the area in here, is equal to A squared. Everyone follow me so far? And if I were to continue this idea, I'm going to draw a box here. And this length, these are all the same as well. So this will be side B. B. And so the area, the area inside here is equal to B times B, right? So it's B squared. And then we have our last one, which I'll go like this. All right, so, and then this one here, it's a slightly different length, but these are all going to be the same length. And this is side C. And there's side C there. So we could say the area of this is equal to C squared. All right, so basically what Pythagorean theorem explains is that we have these boxes here, right? And I'm going to label them all. So this is like, we have box 1. And box 2. And then box 3. So basically what we're saying is boxes 1 and box 2 is equal to the area of box 3. So the area of box 1, the area of box 2 is equal to the area of box 3. Which actually, if we were to look at it, those formulas like this, a squared plus b squared is equal to c squared. So basically, any triangle, it's these two imaginary boxes that were coming off the side here. The area of those two boxes is actually the same as, if you add them up, would be the same as the area of the C. So this is how we know that this rule is true, is because we can measure these things and find that they're true every single time. All right, so this is our theorem right here. And it only works on right angle triangles. So if it's not a right angle triangle, we can't do it. So this must be, actually I'll use the black pen again. This triangle here must be a right angle. Okay, so that's the critical part. Let's write that down. Only works on right angle triangles. Okay. So we can, if we know two sides, we can actually find the third side. Let's color this part in here. So let's take a look at this example right here. We have two sides. All right. To find the length of the longest side of the triangle, we can use that relationship. So right now we have the letter B. It's the one we don't know. Okay. So B equals, we're not sure. But all we have to do to solve for B is B squared is equal to the sum of the other two sides squared. So let's use two other letters here. We're going to use, I'll use X and Y. Right? So in this case here, if we have X is equal to 6 and Y is equal to 10, and it's a right angle triangle, so we're going to say B squared is equal to X squared plus Y squared. And then we can continue on, and we'll substitute in those values. So we're going to put in 6 squared plus 10 squared is equal to B squared. So B squared is equal to 6 times 6 is 36 plus 10 times 10, which is 100. B squared is equal to 136. Now, this is where a lot of people get tempted to stop because they're like, oh, I found the answer, right? That B squared is equal to 136. Except we don't really want just B squared. We want the value of B, right? So we're going to say, but what does B equal? So B equals, we have to take the square root of 136. All right, so we're going to go B equals the square root of 136, which is some number between 11 and 12, which I don't know. If you know, tell me. And I'll put it in there. 136. And I get a value of 11.7. All right. And that's, whoops, rounded off. This is my rounded off answer. So it equals approximately 11.7. Okay? So the key is the longest side is equal to the sum of the two shorter sides. All right? So this is where you would try a couple of these ones here. So you have the two shorter sides, and it doesn't really matter which letter you use. It doesn't, like, the letters are just placeholders. So I have the letter X in this one here, and I'll use the letter C in this one here, because a lot of you are used to seeing C as the longest side. But it doesn't have to be the letter C. It could be any letter, whatever you want to make it. All right? So let's go through it then. So if we have C, the letter C, we're trying to figure out C equals what? So we have to go C squared is equal to the sum of the other two sides squared. Right? So we're going to do 15 squared plus 8 squared. So C squared is equal to 15 times 15 is 225, I believe. And then 8 times 8 is 64. So C squared is equal to 229, 289, 289. So C is equal to the square root of 289. And let's just make sure I didn't screw that up. $17. C equals 17. Now, most of these drawings that I'm going to be doing are kind of to scale. So we can say that 17 is an answer that makes sense to us. If you got an answer that didn't make sense to you, like if I was looking at this triangle here and I got C equals like 128, well, that's not going to work, right? Because obviously that answer doesn't make any sense. So I want you to use some common sense by looking at it going, what do I think this should be? So for example, in this one here, what's a fair estimate? Just a quick question. Any guesses on what this should be? What length it should be? Let's just throw it out there. Anyone?
30.
30, you think?
It should be around like 24, 25. Well, probably like 25.
Yeah, because it has to be bigger than 24, right? It has to be slightly bigger than 24 no matter what. But yeah, 25 is a good answer too. So we know that it should be in somewhere in this range, right? So the point is that if we get a number that's not anywhere near that, it's probably not going to be correct. So let's look at the answers here. So if we're looking to try and find x, right, we have to use our formula again. We take the longest side squared, and we say is equal to, we do the other two sides squared. So we're basically doing the sum of their squares. Sometimes we refer to Pythagorean theorem as the sum of squares because of this, because of that picture we did above, right? Because those two squares there, the sum of those two squares is the bigger one. All right, so let's go back to this here. So we have 5 squared, 25, plus 24 times 24, which I don't know offhand. 576. All right, and we'll do our, we'll sum it up together first. X squared is equal to, and 581, 601. So x is equal to the square root of 601. X equals 24.5. So all good. Your estimates were very good. All right. So I want you to be able to look at those and hopefully, like, you can just eyeball it first and estimate it, and then your answer should be somewhere around your estimation. So the key thing is this last step, is not forgetting the last step, because I don't want just the x squared equals something. I want to know what x is equal to, so I have to remember to do that last step, which is taking the square root. All right, so that's for the longest side. But I know what you're thinking, Mr. Shantz, what if I already know what the longest side is, but I want to know what one of the shorter sides is? Well, I'm so glad you asked that. Let's just move on here. So we have another example, and now we have the longest side, right? We are given the hypotenuse. So we're given the longest side, and now we have to find out for one of the shorter sides. So we have to rearrange our formula a little bit. So, for example, instead of adding the two, right, before it would have been like this, 21 squared is equal to x squared plus 15 squared. Well, instead of adding the two together, what we're doing is we have to subtract to get to x squared, because to rearrange this formula to solve for x squared, so I'm going to say rearrange to solve for x squared. It's going to look like this. We have to get rid of this 15. We have to get rid of this one right there. So what we're doing is we're subtracting it. Right? We're subtracting 15 squared. And that gets rid of this one, and it gets rid of that one. But if it goes on that side, it goes on this side as well. So what we're actually doing is x squared is equal to 21 squared minus 15 squared. All right, so we have x squared is equal to 21 minus 15 squared. So again, I'm going to do this the longer way. You might just put in your calculator 21 squared minus 15 squared, but I'm going to do 21 squared first to figure out what that value is, just to confirm it. So I have 441, and 15 squared is 225. So I'm left with 216. All right, and then we take the square root of 216. And we're left with this. X equals 14.7. And there's our answer. So all we're doing differently essentially is subtracting. You just take, if you're looking to solve for one of the shorter sides, just take the longest side, and subtract the other side you know, and that's what you're going to get, right? So take the longest side and subtract the other side that you know. So let's take a couple examples here. So for solving for a, all we do is go a squared is equal to the longest side, which is 15 squared, subtracted by one of the short sides. So we have 225 minus 49. That's a squared, a squared. A is equal to, and then last thing we know is we're going to take the square root. So if we subtract the 40 first, we're down to 185. 185 minus 9 is 176. So we're finding the square root of 176. A equals 13.3. And then we'll verify that it makes sense. We're going to look at our drawing. Does 13.3 make sense? It does, because it's less than 15 and it's more than 7, which we can say visually lines up well with that triangle. All right? Let's look at this last one here. So again, we have the hypotenuse, right? Here's our hypotenuse as well. So we have the hypotenuse. So we take b squared is equal to the hypotenuse, or the longest side squared, subtracted by the other side that we know. And we got 144 subtracted by 81. So let's subtract the 80 first. 144 divided by, or subtracted by 80, we're up to 64. And then subtract another 1, and we're at 63. So b is equal to the square root of 63. And b equals almost 8. Are we going to round off to 8? Or is it going to be 7.9? 7.9 it is. All right, so there's our answers. Okay? So we're able to solve for different sides. So that's with just pure basic examples with numbers. But what if we have questions that are kind of word problems, right? And you might think, how is this actually important for me? So for example, let's say you go to buy a TV. When you're looking at a TV, the length or the size of the TV is not the actual length across from it. It's actually the diagonal. So if we have a computer screen, let's say in this drawing here, or in this question here, and it's 30 by 22.5. So I'm going to go like this. My drawing's not going to be as good to scale, but we'll give it a try. So 22.5 by 30. All right, determine the length of its diagonal. So that is this part right here. This is what we want to know. And this is what TV screens, they give you. And they do it in inches typically because they're, I don't know, they just follow whatever the Americans do, I guess. So in this case here, we are looking for the diagonal. That's the actual length of the screen, right? So we want to figure out what this is. So if that's 22.5, we can put that right here. 22.5, it's the same on both sides. And the 30 centimeters, the same on both sides. And we want to know what that is. So I'm going to call it C. All right, so if I want to find that, I'll use my formula, c squared equals, and I'll put my two numbers in, 22.5 squared plus 30 squared, because we're looking for the longest side. All right, and now I'm going to skip a step because otherwise it's going to be a lot of writing. So I'm just going to do 22.5 squared plus 30 squared. And I get 1,406.25. And our last step is taking the square root of that number. So we're left with 37.5. And I'll put my units in, because it was in centimeters. So that computer monitor has a screen size of 37.5 centimeters. That's what you'd see on the box. All right? So we could solve it that way. And you could solve it for the other way as well. If you took a measurement of one side, if you wanted to know how big the TV was and you were too lazy to actually look at the serial number on the back of the TV, and you decided that you wanted to use a much more long-standing mathematical equation, you could do it this way. And actually, this equation was kind of the first way that people were actually able to set distances between cities. So what they did was they took the angle from the sun, and they basically assumed directly when they're at noontime, and they could take they could look at the angle of the shadow from an object and assume that they were directly under the sun, and whatever angle that was there, they could figure out their distance. People were able to estimate for distance from the Earth to the sun, or other distances between cities, and eventually they were able to figure out a rough estimate of the circumference of the Earth as well, that the ancient Greeks did. And then they forgot about it for about 1,500 years before people figured it out again. But they were using this Pythagorean theorem, and that was kind of this is kind of the pinnacle of their mathematics at the time. All right, so Kristen, I know you're on today, so you have your own question. Lucky you. So Kristen's changing light bulb. It only takes one Kristen. It doesn't take multiple Kristens, which is a good thing. And she rests a 4-meter ladder against a vertical wall. All right, so let's do a nice drawing here for Kristen. There's the wall, and we need a ladder. Right, and I'll make it like a 3-dimensional ladder here because Kristen lives in 3 dimensions. And of course, for this drawing, we need Kristen. I mean, come on. Kristen, we're going to give you shorts because it's nice out.
All right.
And you have glasses, so I'm going to put the glasses on there. And I haven't seen you in a while, but I'm assuming you haven't had a haircut for a while, so your hair is really crazy now. Okay. Okay, so there's Kristen. And let's look at our measurements then. All right. So we have a 4-meter ladder wall. So if the ladder is 4 meters long, that's going to be 4 meters. And then the base is 1.4 meters from the wall, so 1.4 meters. That's this distance right here. All right, so how high up the wall does the ladder reach? So we want to know this. I'm going to call height is equal to h. And we want to know what it is. So we're solving for that. We know the longest side. We know one of the shorter distances. We need to solve this for Kristen because otherwise Kristen won't be able to sleep at night and will be like staring at the ceiling, wondering about this math question the whole time. So we're going to take our equation. And again, we're not solving for the longest side. So to solve for h, you take the longest side squared and subtract the shorter side like that. And it's h squared. So we have 16 subtracted by 1.4, which is 1.96. So h squared is equal to root of 16. I'm getting 3.7. It's my final answer, but here, I'll go like this. All right, so there's our height. And we'd say, therefore, the ladder reaches 3.7 meters up the wall. And now Kristen could sleep at night, knowing that answer. All right. Okay, so last one. Calculate the area of a triangular sail on the sailboat. Okay, this question's a little bit different because we're going to use Pythagorean theorem, but it's a two-parter because we want to know the area. Except, let's figure out what the area of a triangle is. Anyone remember offhand the area of a triangle? Formula?
Base times height divided by 2.
Awesome, thank you. Base times height divided by 2. So we have that. Now let's look at our dimensions. So we have the base. Like if we turn this triangle sideways, it would look like this, right? And we know the base is 8 centimeters. And we know that's 11 centimeters. But we don't know what this is, right? And that's our height. So we have to solve for the height first. So let's solve for the height first. And we know that it's not the longest side. So we're going to take that side, h squared is equal to the longest side squared subtracted by one of the shorter ones. So 121 subtracted by 64. And 121 plus or minus 60 is 161. Minus 4 is 57. So h squared is equal to 57. So h is equal to the square root of 57. And h is equal to 7 point. I'm going to round up to 2 points here. I'm going to use two numbers there. 7.55, just because it's a little more accurate, because we're solving for area. So part 2 is find the area. All right, and since we already said area is equal to base times height divided by 2, let's put those values in. So base was 8 centimeters times 7.55 divided by 2. And I got 30.2. And we use our units, centimeters squared. So therefore, the area, oops, that's ugly. The area of the sail is 30.2 centimeters squared. Brilliant! I feel like I've achieved a lot now that we solved that. All right, so last example. Then the rest is for you for homework, which I will not be checking. It's up to you. There's going to be a quiz I'll post on Wednesday, and it's going to have some Pythagorean theorem questions on it, similar to the ones we've seen here. All right, so last one here. Find the area of the isosceles triangle. Hint, use a median. Median meaning like halfway point, which would be right there. And if we use a median, we'd be able to solve for this, which we know would represent the height, right? We need to solve for that. Okay, so for finding the area, we need to find the height of the triangle first. So we're going to use this, which we know this is going to be 1 centimeter. So we're going to have area 1 and area 2. So area total is equal to, since area 1 and area 2 are the same, we could actually just do 2 times area 1, or you could say area total is equal to area 1 plus area 2. It doesn't really matter. So anyway, let's solve for what area 1 is equal to. Area 1 is equal to base times height divided by 2 is equal to 1 times 6 divided by 2 is equal to 3. So area total is equal to 3 plus 3. Area total is equal to 6 centimeters squared. All right. So the rest is yours to do. Yeah, not a lot of questions there, but something to practice in the meantime. If you are struggling, again, as always, send me a message. I'm happy to respond to it. And yeah, and I'll post again tomorrow. We're going to do a lesson tomorrow at 12:30, and the quiz will be up as well. Any questions?
No.
No? All right. So I can't stop the lesson there. And I'm going to stop my live stream.